We will now take a look at how a person living on a carousel can communicate with a taxi driver living in a rectangular grid world of streets and avenues. In order to do that, we need to figure out how to lay out the angular measure, the radian measure, along a line. And we can illustrate this with a simple cable wound or wind. And if I pull this, you see how the angular thing is transformed into a rectangular thing. I'm pulling this thing out, and it lays out the angular measure along a line. And if we do this, as you can see in this animation here, you can see how the carousel person is turning round and round, and his position is projected on the two axes. And you can see how the cable wind is working along the line to give the angular measure. So we are projecting the horizontal component of the circular motion and the vertical component as a function of the angular measure, as one says in mathematics. And these functions are called the cosine function and the sine function. The sine function is the green curve, and you see that being laid out along the x-axis. The cosine function is the blue curve, and that curve is being laid out along the y-axis, the vertical axis. But normally we draw these functions as functions where the vertical is depending on the horizontal. Y equals f of x, as we say in mathematics. And that's why we have reflected the blue curve into the purple curve. So the purple curve has the equation y equals cosine x, and the green curve has the equation y equals sine x. In order to figure out the equation of the circle, we can think of a ball rolling around in a city based on streets and avenues, like it could be New York. Imagine, for instance, building a monorail, a circular monorail system. You can see the ball rolling around here, knocking down some buildings in order to prepare for the railway. And the question is, how would you describe that railway in terms of streets and avenues? That's what we call the equation of the circle. And we see here, when you project the ball along the streets, you get the number of avenues. And when you project the ball along the avenues, you get the number of streets. That's laid out here in a coordinate system centered on what you could call ground zero. And in terms of this coordinate system, where the streets, the blue line is the 0th street and the green line is the 0th avenue, then we can describe the circle using Pythagoras' theorem. And the red point is then described by the equation street number squared plus avenue number squared is equal to the radius squared. That's the equation of the circle. It's just Pythagoras' theorem applied to New York City.